Welcome to Stack. Stack, as well as queue, are often used as programmers' tools during the operation of a program. You've probably heard of a stack before, right? But if not, I'm going to take you on the tour. Let's get right into it with Stack. A stack is a linear data structure, which means the elements are placed one after the other. An element can be accessed only after accessing the previous elements. You can consider a stack like a pile of plates placed on top of each other. Each plate below the topmost plate cannot be directly accessed until the plates above are removed. Plates can be added and removed from the top only. Each plate is an element and the pile is the stack. In programming terms, each plate is a variable and the pile is a data structure. Stack is an ordered list where the new item is added and an existing element is deleted from only one end, called the top of the stack, TOS. As all the deletion and insertion in a stack is done from the top of the stack, the last element added will be the first to be removed from the stack. That is the reason why the stack is called the last in first out, LIFO, type of list. In the pushdown stacks, only two operations are allowed: push the item into the stack, and pop the item out of the stack. The push adds an item to the top of the stack, pop removes the item from the top. You might be wondering why a programmer needs to learn how to put a plate on a pile and take the plate out from the pile. Let's find the answer to it. You are assigned the task of reversing a string. How would you do it? Start selecting a character from the string and copy it into the new location one by one. Back to where it all started. Now, let us copy these items from the top into the original location. Great, we have successfully reversed a string using the property of stack, the new memory. Inserting and removing were only allowed from the top. This way stack is used in programming. The stack can be implemented in two ways. The static implementation uses arrays to create a stack. Static implementation, though a very simple technique, but is not a flexible way of creation, as the size of the stack has to be declared during program design. After that, the size cannot be varied. Dynamic implementation is also called linked list representation and uses pointers to implement the stack type of data structure. Initially, the topmost element from the array is 5. Performing a pop operation deletes the topmost element 5 from the array and makes 4 the topmost element. Now, on performing push operation to add element 5, the element is added and is made as to the topmost element. Initially, the topmost element in the linked list is 4. Performing a pop operation deletes the topmost element 4 from the list and makes 3 as the topmost element. Now, on performing push operation to add element 4, the element is added and is made as to the topmost element. Although stack is a simple data structure to implement, it is very powerful. The most common uses of a stack are: to reverse a word, put all the letters in a stack and pop them out. Because of the LIFO order of stack, you will get the letters in reverse order. In compilers, compilers use the stack to calculate the value of expressions like 4 plus 2, 3, 5 to 7, by converting the expression to prefix or postfix form. In browsers, the back button in a browser saves all the URLs you have visited previously in a stack. Each time you visit a new page, it is added on top of the stack. When you press the back button, the current URL is removed from the stack, and the previous URL is accessed. The following are the two basic operations that can be performed on a stack. Push, add an element to the top of the stack. Pop, remove the top element, and might return it. Furthermore, the following additional functions are provided for a stack in order to check its status. Peek, return the top element of the stack without removing or deleting it. Is empty, check if the stack is empty or not. Is full, check if the stack is full or not. When a new element is added to the top of the stack is known as push operation. Pushing an element in the stack invokes adding of the element, as the new element will be inserted at the top. However, before inserting the value, we must first check if top equals max 1, because if that is the case, then the stack is full and no more insertions can be done. If an attempt is made to insert a value in a stack that is already full, an overflow message is printed. Push operation involves the following steps. Step 1 - checks if the stack is full. Step 2 - if the stack is full, produces an error and exit. Step 3 - if the stack is not full, increments top to point next empty space. Step 4 - adds data element to the stack location, where the top is pointing. Step 5 - returns success. When an element is deleted from the top of the stack, it is known as pop operation. The stack is decreased by 1 after every pop operation. However, before deleting the value, we must first check if top equals null, because if that is the case, then it means the stack is empty and no more deletions can be done. If an attempt is made to delete a value from a stack that is already empty, an underflow message is printed. Push operation involves the following steps. Step 1 - checks if the stack is empty. Step 2 - if the stack is empty, produce an error and exit. Step 3 - if the stack is not empty, accesses the data element at which the top is pointing. Step 4 - decreases the value of the top by 1. Step 5 - returns success. Peek operation allows the user to see the element on the top of the stack. The stack is not modified in any manner in this operation. Is full. This function checks if the stack is full or not. Is empty. This function checks if the stack is empty or not. To prevent performing operations on an empty stack, the programmer is required to internally maintain the size of the stack, which will be updated during push and pop operations accordingly. Is empty conventionally returns a Boolean value, true if size is 0, else false. These are the time complexities for push and pop operations that can be performed on the stack data structure. Push operation, O1. Pop operation, O1. The time complexities for push and pop operations are O1 because we always have to insert or remove the data from the top of the stack, which is a one-step process. I hope you are clear with a useful data structure, stack. Before having a quiz session, let's have a look at the key points to refresh your mind. A stack is basically a list with insertions and deletions permitted from only one end, called the stack top, so it is a data structure that exhibits the LIFO property. The operations that are permitted to manipulate a stack are push and pop. One of the important applications of a stack is to reverse a string in the programming language.